We stand on a small blue world, adrift in a vast black ocean, and yet, for most of our history, we believed that ocean itself had an edge. Once, our ancestors watched the sun vanish behind the horizon and assumed the world simply stopped there. Sail far enough, they thought, and you would fall off the rim into a dark abyss. Then sailors set out into that fearsome unknown, and each horizon they crossed revealed another one beyond. The edge receded. The world was round, not flat. The boundary had been an illusion born of our limited sight. We have carried that same yearning for an edge into the heavens. We build telescopes that peer farther and farther, hoping that one day the cosmic map will come to an end, that there will be a final wall, a last glowing shell beyond which there is only emptiness. We want to see where it all stops, but every time our instruments improve, the universe extends further. The edge recedes again, as if taunting us. Here is the paradox that unsettles both astronomers and dreamers. We can now detect galaxies whose light has traveled for 13.8 billion years to reach us. Because the fabric of space itself has stretched during that journey, those galaxies are now about 46 billion light-years away. That is the radius of the observable universe. And yet, scientists insist that is not an edge. We have mapped a sphere of what we can see, but the sphere is not a wall. It is only the horizon defined by the speed of light and the age of the cosmos. Beyond it, space continues, possibly forever. This is the first shock. There is a distance beyond which no signal has yet reached us, a shell beyond which lies more universe we cannot observe. The limit is not carved in stone. It is woven into the physics of time and light. The universe may be far larger, perhaps infinite, and we are trapped inside a growing bubble of visibility. Imagine standing on the deck of a ship in the middle of a dark sea. Around you, the water seems to end in a perfect circle at the horizon. But you know it is not a real edge. It is only the limit of your sight, determined by the curvature of the world and the height of your eyes. Sail forward, and the circle moves with you. That is what the cosmic horizon is like. Wherever you go, you will always see a horizon at about the same distance. There is no rim to reach, yet the mind resists this idea. We crave borders. We imagine the universe as a balloon floating in a dark room. If it is expanding, we picture it swelling into some external void. But cosmology tells us there is no external space into which it grows. Space itself expands. The balloon analogy is useful but misleading, because the real universe is not a balloon in a room. It is more like the two-dimensional surface of a balloon without the inside or the outside. A creature living on that surface could move endlessly without ever finding an edge, yet the surface has a finite area. In a similar way, our three-dimensional space could be finite, yet unbounded. Think about what that means. A traveler might set off in a straight line through the cosmos, never turning, always forward, and after a span of unimaginable distance and time could, in theory, return to the point of departure without ever crossing a boundary. The universe could wrap around itself like a higher dimensional loop. We do not know if this is true. Observations so far suggest the large-scale geometry of the universe is very close to flat, which would imply either it is infinite or so large that any curvature is beyond our detection. But the possibility that space is finite, yet has no edge, still lingers like a profound riddle. The idea of no outside haunts the imagination. If there is no beyond, then what is the universe expanding into? The best answer science can offer is that it expands into itself. Every region of space grows more distant from every other region, not because it is rushing into a larger arena, but because the metric that defines distance itself is changing. Two galaxies drift apart as if carried on a stretching fabric. There is no external stage, only the actors, and the space between them growing wider. Pause for a moment and let the strangeness sink in. We have grown up with a sense of inside and outside. Every container has a wall. Every map has a border. But when we try to apply that intuition to the whole of reality, it breaks down. To ask what lies beyond the universe is to ask what lies north of the North Pole. The question seems natural, but the very terms no longer make sense. We can measure the rate at which the universe expands, its Hubble constant, by studying how distant galaxies' light is stretched into redder wavelengths. We can model how that expansion accelerated when dark energy became dominant billions of years ago. We can even predict that distant galaxies will someday slip beyond our horizon as the expansion outpaces the reach of light itself. But none of these insights provide a final border. They only deepen the sense that we live inside an ever-receding bubble of knowledge. For early humans, the edge of the world was a line on the ocean. For modern humans, the edge of the universe is a horizon in time. We look outward and see the afterglow of the Big Bang. The cosmic microwave background, a faint pattern of light released when the universe was only 380,000 years old. Beyond that veil, no light from earlier epochs can reach us. The universe itself was opaque before that era. That veil is sometimes called the surface of last scattering, and it is the deepest wall our telescopes can see. Yet, it is not a true wall. It is more like a photograph of the young universe imprinted on the sky. The expansion has carried that primordial light outward so that we can now receive it as a dim whisper from all directions. What lies beyond that ancient curtain? Perhaps more galaxies. Perhaps an infinite stretch of space we will never behold. Perhaps the topology of the cosmos loops back on itself. Perhaps other universes, separated from ours by a gulf we cannot cross. We do not know, and that ignorance cuts deeper than any lack of technology. It reveals the limits of our place in time. We are creatures born late in cosmic history, living on a planet that circles an ordinary star, able to see only as far as light has had time to travel since the beginning. Beyond that horizon, reality goes on without us. Here, wonder and dread entwine. To think that there is more, possibly infinitely more, beyond our reach fills the mind with awe. But it also confronts us with an unsettling thought. Our map of reality will always be incomplete. There will always be a frontier that recedes as we advance. No generation will ever say, "We have seen it all." By the end of this journey, you will understand why the question, "Where does the universe end?" may be the wrong question to ask. For now, hold on to the paradox. We can see 46 billion light-years away, yet we may never find an edge. We inhabit a cosmos that might be finite in volume, yet without borders, or infinite and still expanding, or part of something even larger, whose nature we can barely imagine. The mystery is not merely about distances. It is about the very meaning of place and direction when applied to everything that exists. We once feared falling off the edge of the world, Now we face a stranger fear, that there is no edge at all, and that the quest for it will go on forever. We look out into the night sky and imagine that the stars mark the outer walls of a grand celestial chamber. But that illusion dissolves under closer thought. Every pinprick of starlight is a messenger from the past, 80 to a pulse of radiation that has crossed the dark ocean for years, centuries, even billions of years before striking our eyes. The universe we see is not the universe as it is, but as it once was. The farther we look, the further back in time we peer. Our maps are mosaics of ghostly light that has traveled across expanding space to reach us. There is a number that startles even seasoned astronomers. The oldest galaxies we can detect emitted their first faint glow over 13 billion years ago, not long after the universe's birth. But because the fabric of space itself has stretched during the time their light was in flight, those galaxies are now more than 46 billion light-years away. In other words, we can observe them as they were when the universe was young, but their present-day locations lie far beyond the distance that they're ancient. Light has traveled. The cosmos has grown. While the message was en route, this is the first key to understanding the cosmic horizon. Light does not move through a static backdrop. The backdrop itself stretches. Imagine drawing two dots on a balloon and then inflating it. The dots drift apart not because they crawl across the surface, but because the surface expands beneath them. If you could send a signal from one dot to the other, it would have to chase its target while the balloon keeps swelling, and the distance it finally reports when it arrives would be larger than the distance when it was launched. The finite speed of light is the second key. We live in a universe with a beginning in time, so there has been only a finite amount of time for light to travel since the Big Bang. That means there is a maximum distance from which we can receive any signal, a spherical limit defined by the age of the universe multiplied by the speed of light, modified by the stretching of space. That spherical limit is what cosmologists call the observable universe. It is not the universe itself, merely the part of it we can see. To grasp this, picture a stone tossed into a still pond. The ripples spread outward in all directions, carrying information about the disturbance. If you watch from the shore, you can see only the waves that have had time to reach you. The pond extends beyond that moving circle, but until the ripples arrive, you have no knowledge of it. In the same way, we occupy a cosmic shoreline. The light waves from distant regions have been spreading since the moment of the Big Bang, and only those that have had time to cross the growing gulf are part of our visible domain. Yet there is another twist. The space between us and the distant galaxies is not merely empty. It is an active participant in the cosmic drama. During the first tiny fraction of a second after the Big Bang, the universe underwent a phase called cosmic inflation, an episode of mind-bendingly rapid expansion that magnified microscopic quantum fluctuations into vast ripples in density. Regions that were once close were pushed so far apart that light could never have passed between them since. Inflation set the stage for the large-scale structure we see today, the great filaments and voids of galaxies, and it left behind a subtle pattern in the cosmic microwave background, the afterglow of the primordial fireball. The cosmic microwave background, or CMB, is itself a horizon. It is the oldest light we can observe, a bath of radiation released when the universe cooled enough for neutral atoms to form, about 380,000 years after the Big Bang. Before that epoch, the cosmos was filled with a fog of charged particles that scattered light, making space opaque. When the fog cleared, photons streamed freely across space, and after billions of years of redshifting as the universe expanded, they now arrive as microwave radiation coming equally from every direction. We detect it as a nearly uniform glow with tiny fluctuations that encode the seeds of cosmic structure. Beyond that surface of last scattering, there is still universe, but no direct light has reached us from it. Our instruments cannot look deeper in the ordinary sense. To probe earlier times, we rely on neutrinos, gravitational waves, and mathematical inference. The CMB is like the edge of a photograph taken in infancy. The child has grown into an adult, but the photo remains our deepest direct glimpse of the past. Now consider what the expansion is doing today. Space itself is stretching at such a rate that very distant galaxies recede from us faster than light. Not because they are breaking some universal speed limit, but because the metric that defines distance grows between us. Their light is still emitted and still moves locally at the speed of light, but the gulf it must cross widens so quickly that most of it will never reach us. We can say we see these galaxies as they were billions of years ago, but we will never see their present. They are already slipping beyond a more subtle limit, the cosmic event horizon. This creates a profound paradox. The faster the universe expands, driven by the mysterious force we call dark energy, the more regions become forever inaccessible. Even if we could build ships that traveled at nearly the speed of light, there would remain realms we can never visit, stars whose glow will never reach our telescopes. The horizon of what we can, in principle, interact with shrinks, not because the universe itself shrinks, but because it races away. To sense the scale of this limit, imagine again our pond. Suppose the ripples move at a fixed speed, but the pond's surface grows wider as they spread. Beyond a certain distance, the shore recedes faster than the waves advance, so no ripple will ever arrive. You could cast 1,000 stones, but their influence would remain confined within an expanding circle. In the cosmic pond, our observable universe is that circle. The rest of the pond lies forever beyond the reach of our ripples. The distinction between the observable horizon and a true border cannot be overstated. There is no cosmic wall at 46 billion light-years. A galaxy just beyond that radius is not perched on the edge of existence. It is simply too remote for its light to have arrived. Nor is the event horizon a fence. It is a consequence of the changing geometry of space-time. We can describe it mathematically. We can even measure its effect on the future flow of light. But there is no tangible surface to touch. And yet, to the human mind accustomed to boundaries, this is difficult to accept. We speak of the edge of the universe as if it were a real thing. We draw diagrams with circles marking the observable region, as if beyond the line there were nothing. But the line is a feature of our perception, not of the universe itself. We live in a bubble of information whose size is set by the age and the expansion history of the cosmos. The bubble is not a container. It is a record of what has had time to reach us. The philosophical implications are as humbling as the physical. If we cannot see or ever reach beyond the horizon, can we claim those unseen realms exist? For most of scientific history, existence has been tied to observability. But the equations that govern space and time predict more. More galaxies, more structures, perhaps an infinity of them, beyond what we can ever verify. The question is no longer purely scientific. It is almost existential. Does the universe consist only of the observable, or does it include all that would be visible if we waited forever? And what if waiting forever is not enough? To map the cosmic horizon is to draw the limits of knowledge itself. We use the faint radiation of the CMB as a reference shell. We chart the distribution of galaxies within that shell, like lights strewn across an enormous three-dimensional web. We measure the acceleration of their recession to infer the presence of dark energy. We even detect the slight distortions in that ancient radiation caused by intervening clusters of galaxies. Piece by piece, we construct a picture of a universe 93 billion light-years in diameter. Yet we know the picture covers only the part lit by messages that have had time to arrive. Some cosmologists speculate that the global shape of the universe could be finite, curved like the surface of a higher dimensional sphere. If so, the observable region is just a small patch of the whole, like a tiny circle drawn on the skin of an elephant. Others argue that the universe is infinite and flat, extending without bound in all directions, and that inflation stretched any initial curvature beyond detection. Either way, our horizon is not the edge of all that is. When we think of infinity, we imagine an endless chain of stars fading into distance. But the deeper mystery is that infinity may lie not in the stars themselves, but in the space between them. If space is infinite, then the observable bubble is just a local glimpse, a finite window cut out of an endless fabric. If space is finite yet unbounded, then even infinity is a kind of illusion. There is no limit, but also no outside. Every improvement in our telescopes has been an act of expanding the known world. The first primitive lenses revealed moons circling other planets. Larger telescopes uncovered the galaxies beyond our own. Modern observatories see quasars blazing in the remote past and map the subtle polarization of the cosmic microwave background. Each advance enlarges the sphere of what we can describe. Yet, at the same time, each discovery underscores the sobering truth. The universe itself is not obliged to become fully knowable. There is poetry in that limitation. It is as though the cosmos whispers, "You may look this far and no farther," inviting us to wonder about the unseen. The map is not the territory. The observable sphere is a candle-lit room in a night without walls. Beyond its glow, perhaps more galaxies, perhaps other cosmic bubbles born in other inflations. We may never know. Our horizon is not merely a feature of physics. It is a mirror held up to our curiosity. We began with a shock. The most distant galaxies appear as they were 13 billion years ago, yet are now 46 billion light-years away. We confronted a paradox. The faster the universe expands, the more of it slips beyond reach. We recognized that the edge we see is not a border, but a horizon defined by time, light, and the growth of space itself. We traced the story back to the flash of the Big Bang and the inflationary swell that made the observable bubble possible. And now we face the cliffhanger that follows inevitably from these revelations. If we cannot see it, if we cannot even in principle reach it, can we meaningfully speak of it as existing? The question waits in the silence beyond the horizon, challenging not just our science, but our very notion of reality. There is a thought experiment as old as the first sailors who dared the open sea. Imagine you set out in one direction, west, say, sailing straight without ever turning. You cross an ocean, then another, pass through storms and calm waters, and keep going. Weeks turn to months, months to years, yet you never find an edge, never reach a final cliff where the world ends. One day, to your astonishment, you arrive back where you began, approaching the same familiar coastline from the opposite horizon. You have circled a world that seemed flat and endless, but was in fact finite and curved. Replace the ship with a starship and the sea with space itself, and you have the first hint of what physicists mean when they say the universe could be finite, yet unbounded. The words feel contradictory. Finite means limited, unbounded means without edge. But together, they describe something subtler, a space that closes back on itself. You can travel forever without encountering a wall because there is no wall, only a continuous geometry that folds without end. This idea took shape with Einstein's general theory of relativity, published in 1915. General relativity replaced the old view of space as a static stage with the insight that space and time together form a single fabric whose geometry is shaped by the presence of matter and energy. Galaxies, stars, planets, even light itself follow paths determined by the curvature of this fabric. To understand the universe's large-scale structure, we must therefore ask how that fabric is bent by the total energy it contains. Relativity tells us that space can have three broad types of global curvature. It can be positively curved, like the surface of a sphere. It can be negatively curved, like a saddle. Or it can be flat, like an infinite plane. Which of these describes our cosmos depends on a single quantity: the average energy density of the universe compared with a critical value determined by the expansion rate. If the density is higher than critical, gravity slows the expansion and space curves inward like a ball. If it is lower, expansion wins and space curves outward like a saddle. If it is just right, the expansion and gravity balance so that space is flat. The shape matters because it defines the possible destinies of travelers and of the cosmos itself. In a positively curved universe, you could in principle launch a starship in a straight line and, ignoring the practical impossibility of crossing billions of light years, eventually return to your starting point without ever encountering a boundary. The universe would be finite in volume, but without an edge, like the two-dimensional surface of Earth extended into three spatial dimensions. In a negatively curved or flat universe, by contrast, such a path would never bring you home. Space would extend without limit, although in the negatively curved case it would do so with a strange hyperbolic geometry. To picture finite but unbounded space, consider an ant living on a balloon. The ant's world is two-dimensional. It can crawl north, south, east, or west across the balloon's surface, but it has no concept of up or down into the third dimension. No matter how far it walks, it never reaches an edge. Its straightest possible path, a geodesic, is a great circle that eventually loops back on itself. The surface has no boundary, yet it encloses a finite area. If the ant could somehow look outward into the third dimension, it would see that its world is curved. But from within, all it can detect is that parallel lines eventually converge. Now extend the analogy to us. We inhabit a three-dimensional cosmos. If that cosmos is the three-dimensional surface of a higher-dimensional hypersphere, we likewise have no access to the outside. Our straightest paths may loop back on themselves across unimaginable distances. To us, space appears unbounded even though the total volume is finite. This picture, though, is not the only possibility. Mathematicians have long explored other topologies for space, such as the three torus. A torus is the surface of a donut. In a three-dimensional version, traveling in one direction could bring you back from the opposite side, as if space were a hall of mirrors endlessly repeating itself. Light from a distant galaxy could take multiple routes around the toroidal loops, so we might see multiple images of the same object at different epochs of its history, scattered across the sky. Astronomers have searched for such repeating patterns in the cosmic microwave background, but so far none has been confirmed. The search continues, for the cosmic hall of mirrors remains a hauntingly beautiful possibility. Even in a universe that appears locally flat, topology can still play tricks. A room with parallel walls is locally flat, but if you identify opposite walls, say, by gluing them together in thought, the room becomes topologically equivalent to a torus. A traveler moving straight ahead will re-enter from behind without ever hitting a wall. Thus, geometry and topology, though related, are not the same. The former describes local curvature, the latter the global connectedness of space. The universe could be flat, yet still fold back on itself in ways that defy naive imagination. The curvature we can measure is astonishingly close to zero. Observations of the cosmic microwave background by the WMAP and Planck satellites reveal that, on scales of billions of light-years, space is flat to within a tiny fraction of a percent. This suggests either that the universe is truly infinite or that it is finite, but so large that its curvature is undetectable in our observable region. Inflation, that brief burst of exponential expansion in the early universe, offers a natural explanation. It would have stretched any initial curvature so enormously that our patch of the cosmos now appears flat, like a small region on the surface of a vast sphere. Still, the possibility of finite yet unbounded space lingers. One of the most mind-bending implications is the absence of any privileged center. In a curved, closed universe, every location is equivalent. Just as no point on the surface of Earth is the center of its surface, no galaxy would be at the center of the cosmic volume. Expansion would carry every region away from every other, and the geometry itself would set the stage for that motion. Imagine a luminous Mobius strip spinning in the dark, a ribbon twisted once before joining its ends. A two-dimensional being confined to its surface would find that moving along what seems a straight path brings it back inverted, without ever crossing a boundary. Such exotic topologies are mathematically consistent with relativity, and while we have no evidence that our universe is a Mobius-like manifold, the image captures the strange freedom we have in thinking about space when we lift the demand for edges. Einstein himself was drawn to the idea of a closed universe. In his first cosmological model, he envisioned a static, finite, positively curved cosmos, balanced by a repulsive cosmological constant. Later, as evidence for expansion emerged, he abandoned that particular model, but not the insight that the global geometry is determined by energy density. The story of modern cosmology is in many ways the story of trying to read the shape of space from the faintest signals. The distribution of galaxies, the bending of light by massive clusters, the subtle harmonics imprinted in the microwave background. The philosophical implications are no less remarkable. If the universe is finite yet unbounded, then questions like, what lies beyond, lose their meaning. There is no beyond, only more of the same space curving back on itself. Our desire for a final exterior gives way to the realization that there may be none, that the cosmos is self-contained. But then a deeper mystery emerges. If space is like the surface of a sphere or the skin of a torus, what is it curved in? We picture a balloon curving in three-dimensional space. But if space itself is curved, it must curve within something yet higher dimensional. General relativity sidesteps this by describing curvature intrinsically. The geometry of a surface can be defined by how lines behave on it without referring to any embedding outside. Still, the imagination rebels. We want to know what surrounds the hypersphere, even though the question may be meaningless. There is both comfort and unease in the notion of a self-contained cosmos. Comfort, because it removes the need for an outside we cannot reach. Unease, because it suggests that the whole of existence might be a closed loop, finite in extent, yet without boundary, with no frontier to cross. We are used to frontiers, to the sense that beyond the next ridge or ocean there lies something new. A universe that folds back on itself denies us that final discovery. It tells us that the ultimate elsewhere may be, in some inconceivable way, also here. Contemplate for a moment the Hall of Mirrors universe. Light from a distant galaxy could travel around the cosmic loop multiple times, so that we might see several images of it. Some from when it was young, some from when it was older, all arriving along different paths. In principle, we could look across the sky and see a patch of primordial gas that is, in fact, the far distant image of our own galaxy in its infancy. The sky would be a grand time-layered kaleidoscope. This is not fantasy. It is a real, testable consequence of certain finite topologies. That we have not yet seen such repetitions either means the universe is vastly larger than the observable patch, or that its topology is of a more subtle kind. General relativity further reveals that space and time are intertwined. If space is closed, time may have its own curious global properties. In certain solutions to Einstein's equations, closed time-like curves arise, paths in space-time that loop back on themselves. While such features seem to invite paradoxes and probably do not describe our actual universe, they hint that the full geometry of space-time may be stranger than any simple picture of surfaces and loops. The question of shape is not merely academic. It influences how the universe evolves. A positively curved universe with enough matter might one day halt its expansion and collapse in a big crunch, though the presence of dark energy appears to have made this unlikely. A flat or negatively curved universe can expand forever. Geometry, destiny, and origin are entwined. The pursuit of cosmic geometry has required heroic feats of observation. Astronomers measure the angles of giant acoustic ripples frozen into the distribution of galaxies, the so-called baryon acoustic oscillations, to gauge curvature. They scrutinize the polarization of the microwave background to glimpse the signature of primordial gravitational waves that inflation may have left. They map the faint arcs of background galaxies distorted by intervening mass, using gravitational lensing as a probe of the cosmic web. Each clue refines our sense of whether space closes or opens. Yet even if we someday determine the precise curvature and topology of the observable universe, the ultimate question will linger like a riddle. Why does space have that shape rather than another? Mathematics permits a vast landscape of possible manifolds. Physics selects one, perhaps out of necessity, perhaps by chance, perhaps through some deeper principle we have not yet guessed. To know the shape is to know the stage, but not necessarily the playwright. Consider again the sailor on the endless voyage who returns home from the far side. Consider the ant on the balloon, walking without end. Consider a beam of light circling a cosmic loop. carrying an ancient message that one day arrives at the world that sent it. These images are not only metaphors, they are windows into what may be the true nature of reality. A realm where motion has no ultimate beyond, only recurring paths across a finite but edgeless expanse. If such is our universe, then the ultimate map is not a flat sheet, but a self-curving manifold, a three-dimensional surface without border embedded, if at all, only in the imagination of higher mathematics. We may never perceive the curvature directly, for our observable patch may be too small compared with the whole. We may live, like the ant, in a tiny neighborhood that seems flat, unaware of the grand bend that would reveal itself only across distances we cannot traverse. And yet we keep asking, even if space loops back on itself, what lies beyond that loop? The question tugs at the edges of language itself. Beyond presumes an exterior, but if space is self-contained, there is no exterior. Still, the human mind, restless and unappeased, asks for a larger frame. Perhaps there is one, some higher dimensional metaspace of which our cosmos is a curved brain, as certain speculative theories suggest. Or perhaps the question is as misguided as asking what lies north of the North Pole. That is the cliffhanger we must leave hanging for now. We have explored how space can be finite yet unbounded, how its shape is woven from energy and expansion, how it may close upon itself or extend without limit. We have glimpsed Einstein's curved space-time, the hall of mirrors of toroidal topology, the ghostly hints inflation has left in the ancient light. But the next question presses from the dark. If our universe loops back on itself, is that the whole of existence or just one self-contained chamber in a far vaster structure? We have been explorers for as long as we have been human. We learned to walk out of forests, sail across oceans, cross deserts and mountains, always imagining that there was something beyond the next ridge or the next horizon. That habit of mind has carried over into our quest to understand the universe. We instinctively ask what lies outside the farthest galaxy, what surrounds the expanding cosmos. We want to believe that space itself is swelling into some larger room, that the growing sphere of galaxies has a frontier, and that beyond it is a greater, emptier void. But here is the first revelation that unsettles this intuition. The universe's edge, insofar as it has one, is not somewhere out there in the distance. It is a limit of time, not of place. The observable boundary is set not by a wall in space, but by the moment the first light could begin its journey. What lies beyond that horizon is not outside in the usual sense. It is simply elsewhere in the same space, forever beyond the reach of our signals, because there has not been enough time for light to cross the gulf. This defies the instincts we evolved as creatures living in caves and valleys. Our brains are tuned to a world of containers and contents. Every river has a bank. Every island has a shore. Every sky is framed by a horizon. We imagine the universe as another such container, the ultimate box in which all things sit. It is almost impossible to think of an expanse that has no surrounding, a space that is not embedded in something larger. We picture the expanding universe as a balloon swelling into empty air. But the air is a metaphor's trap. There is no cosmic atmosphere into which the balloon grows. Relativity's insight is that space and time together form a self-contained fabric. That fabric can stretch, curve, ripple, but it does not need a larger backdrop in which to do so. When we say the universe is expanding, We mean that the distances defined within that fabric are growing with time. Galaxies recede, not because they are moving through a pre-existing void, but because the very metric that measures the separation between them is changing. Consider the balloon again. A two-dimensional creature confined to its surface can watch the distances between painted dots grow as the balloon inflates. From its perspective, there is only the two-dimensional surface. The third dimension into which the balloon swells is inaccessible and irrelevant. The creature would have no reason to imagine an outside. It could describe the expansion fully in terms of the distances along the surface itself. In much the same way, we can describe the expansion of our three-dimensional space without appealing to a fourth spatial dimension beyond it. The geometry is intrinsic. That is the scientific heart of the illusion of outside. The laws of general relativity describe how geodesics, the straightest possible paths, behave within the fabric of space-time. We can characterize curvature entirely by how nearby geodesics converge or diverge. We do not need to embed the universe in a higher dimensional container to make sense of that curvature. The fabric is self-consistent. Still, our imagination resists. We are accustomed to the idea that an expanding thing must grow into something. A balloon expands into air. A fire expands into the surrounding wood. A ripple spreads across water. We think of growth as invasion, but the universe's expansion is not like that. It is more like the scaling up of a mathematical grid, where the coordinates themselves stretch so that previously neighboring points grow farther apart. There is no external arena. This disconnect between intuition and reality is a clue to the limits of the human mind. Evolution gave us brains for survival on a planetary surface, for throwing spears and reading tracks and finding shelter. It did not shape us to think easily in the language of curved manifolds or self-contained spacetimes. We imposed the frame of boxes and outsides because that frame worked well enough for hunting and farming and voyaging on seas. Cosmology asks us to abandon that frame and to accept that the very stage of existence has no surrounding theater. To approach this alien idea, consider the candle in a dark room. The light spreads outward in an ever-expanding sphere. We might be tempted to say that the illuminated region grows into the darkness. But the darkness is itself just a region of the same room, waiting to be lit. There is no other substance into which the light expands. The expansion is only the growing set of points now touched by the candle's rays. In a similar way, as the universe evolves, more and more of the pre-existing distances between galaxies increase. There is no need for an exterior void. The question, what lies beyond space, is like asking, what lies north of the North Pole? It carries a presupposition that breaks down when applied to the whole. The globe has no northern edge. The pole is the limit of the concept of north itself. In the same way, the universe may be the limit of the concept of space. This realization does not diminish the sense of awe. In some ways, it heightens it. If beyond the cosmic horizon there is not even empty space to drift into, then we are living inside a totality whose boundaries are not walls, but conditions of existence. We are part of the fabric itself. The notion of venturing outside is as meaningless as asking a note in a song to step beyond the music. The philosophical implications ripple outward. If there is no outside, then all talk of the universe expanding into nothing or emerging from nothing must be parsed carefully. What we call nothing is already part of the framework of space and time. Before that framework existed, if it even makes sense to say before, there was no arena for anything to be. We reach here the edge of language. To speak of before space and time or outside the universe may be to string words together without coherent reference. And yet, the human urge to picture a larger frame persists. We imagine a dark void into which the galaxies fly. We imagine an infinite higher dimensional room holding our cosmic bubble. Some speculative theories in physics, such as certain versions of eternal inflation or the multiverse, speak of other regions, perhaps other bubbles, beyond our observable universe, each with its own local space-time. But even these do not require a classical outside. They speak instead of a larger quilt of space-time domains, each self-contained, stitched together by the same underlying physics. This leads to a subtle distinction. To say there may be other regions beyond our cosmic bubble is not to say there is a surrounding space into which our bubble grows. It is to suggest that space-time itself has a broader, perhaps infinite structure with many inflating and cooling patches. The beyond in that sense is not a beyond of location, but a beyond of domain. It is instructive to return to the balloon surface, now dotted with many separate paint patches. Imagine that as the balloon inflates, some patches expand and cool to form thin crusts where life could arise, while others keep swelling. The two-dimensional creatures on one patch may never reach or even observe the others. To them, the expanding edges of their cooled patch may feel like a frontier, yet in truth, they are still part of the same balloon surface. The presence of other patches does not mean the surface expands into an external void. The outside exists only in a higher dimensional sense that has no bearing on their intrinsic geometry. In this light, our craving for an outside begins to seem like a parochial habit, a remnant of our terrestrial experience. We live on a planet with an atmosphere above it and space beyond that, so we imagine nested shells everywhere. But at the largest scale, reality may have no such shells. Relativity teaches us that distance and duration are not absolutes, but relations between events in the fabric. The expansion of that fabric is a change in those relations, not a growth into a pre-existing void. The edge of the observable universe is a horizon of time. We can look no further because there has not yet been enough cosmic time for light to come from further away. That horizon is not a rim in space. It is a moment in the past. This inversion of common sense, an edge of time instead of an edge of place, has profound consequences for how we think about our situation. It means that the frontier we face is not one we can ever cross with ships or probes. We cannot sail to the boundary because the boundary is not a location, but a limit of what can be observed or influenced. In that sense, the ultimate barrier is not physical distance, but the history of the universe itself. The dread and wonder mingle here. Dread, because it confines us. Our cosmic map will never include all that is. There will always be regions whose light will never reach us, even in infinite future time. Wonder, because it suggests that reality is not merely larger than we can see, but structured in a way that transcends our most basic categories of thought. Still, some physicists propose that the observable universe is only one bubble among countless others in a grander multiverse. Each bubble would have its own local physics, perhaps even different constants of nature. Some bubbles might collide, some drift apart forever. Our cosmic horizon would then be not the limit of all existence, but merely the edge of our domain. Yet even this picture does not provide the kind of outside our intuition seeks. The bubbles themselves would be embedded not in ordinary space, but in an inflating space-time whose nature remains mysterious. So we arrive at a curious conclusion. The illusion of outside is powerful, but perhaps fundamentally misleading. The true frontier lies not in some remote location, but in our conceptual frameworks. We have to learn to think in ways that do not rely on containers, walls, and exteriors. We have to accept that the universe may be all there is in the spatial sense, even if there are other domains of space-time inaccessible to us. Reflect for a moment on a candle burning in a vast cathedral. The glow reaches outward, illuminating arches and pillars, revealing distant alcoves. Yet the candle does not expand into a surrounding substance. It merely lights more of the same air that was already there. The flame's sphere of light is like our observable universe, a growing region of what has become visible as time passes. The cathedral stands as it always has. The boundaries of the glow are not walls, but the limit of illumination. Likewise, the universe's edge is not a frontier of place, but of time. To understand this is to take a step toward seeing reality as modern physics does. We must trade the familiar picture of objects in a box for a picture of events in a self-contained continuum. We must let go of the notion of an exterior void waiting to be filled and learn to see the cosmic expansion as an evolution of the distances themselves. And yet, as we surrender that intuitive frame, we glimpse a deeper mystery. If the universe is a self-contained space-time with no outside, why does it have the shape and history it does? Why did it begin in a hot, dense state and expand? Why does it have the properties that allow galaxies and stars and life to emerge? These questions point beyond geometry to something more profound, the nature of the laws that govern the fabric itself. We close this section with that lingering tension. The universe's edge is a horizon in time, not a wall in space. Beyond it may be nothing in the spatial sense. No void to drift into, no stage to step onto. Yet, some physicists suspect there are other regions, other domains of space-time, perhaps even other laws of physics that lie beyond our reach. If that is true, then the illusion of outside conceals a deeper truth, that our cosmic bubble may be only one part of a far vaster whole. If the universe we see is already so vast that the light from its farthest reaches has been traveling for nearly the entire age of time itself, it is tempting to imagine that this is all there is. But many cosmologists believe that our observable cosmos may be just one bubble in a far larger frothing sea of existence. The notion sounds like fantasy, yet it arises naturally from attempts to understand the very beginning of our universe. The more we examine the physics of those first fractions of a second, the more the horizon of everything seems to retreat, revealing the possibility that our cosmic bubble is but one among countless others. The modern story begins with inflation, a theory devised to explain several puzzling facts about our universe. According to standard Big Bang cosmology, the universe emerged hot and dense, and as it expanded, it cooled, allowing the first atoms to form and later galaxies to coalesce. But that simple picture left mysteries. Why is the universe so uniform in all directions? Why is space so nearly flat? Why do we not see relics of exotic topological defects predicted by early models? In the 1980s, physicists such as Alan Guth, Andre Linde, and others proposed that in the earliest instant, the universe underwent a phase of extremely rapid, exponential expansion. This inflation stretched any initial irregularities into near uniformity, flattened any curvature, and diluted away exotic relics. The theory also explains the tiny quantum fluctuations that were magnified to become the seeds of cosmic structure. Yet inflation carries with it a startling implication. In many versions, the process does not end everywhere at once. Instead, it ends in patches, forming bubbles like droplets of condensation, while inflation continues elsewhere. Each bubble can evolve into a universe like ours, cooling, forming galaxies, and perhaps nurturing life, while the space between the bubbles keeps inflating. This process, called eternal inflation, produces a never-ending, ever-growing multiverse, a cosmic froth where new bubble universes are born endlessly in an inflating background. The scale of such a picture defies comprehension. In some models, the number of bubble universes that could have formed since the beginning is not merely large, but effectively infinite. If you gathered all the grains of sand on all the beaches and deserts of Earth, they would not begin to compare. Each bubble might have different physical conditions, different strengths of forces, different particle masses, even different numbers of spatial dimensions. The multiverse would be not merely a repetition of our cosmos, but a vast menagerie of possible worlds. Visualize a cluster of soap bubbles floating in sunlight, their curved surfaces shimmering and touching but never merging. Now imagine that each bubble is itself as large as, or larger than, the observable universe, and that new bubbles constantly bud from the expanding froth. Our entire visible cosmos would be a minuscule sphere adrift in that foamy sea. The distances between bubbles could be so enormous that light would never bridge them. Their horizons would recede faster than signals could travel. This vision carries a double-edged emotional weight. On one hand, it enlarges our sense of reality to a scale almost beyond words. On the other, it diminishes the centrality of our own cosmos. We are no longer part of the entire stage, but inhabitants of a single chamber in a boundless cosmic honeycomb. The multiverse idea is not confined to inflationary models. String theory, a candidate for a unified description of all forces and particles, predicts that there are many possible ways to compactify its extra dimensions, leading to a vast landscape of possible vacuum states. Each choice yields a universe with its own physical constants. If the early universe sampled this landscape, different regions could settle into different vacua, each with its own local laws of nature. Our bubble might be merely one such region, tuned by chance or selection to allow galaxies and life. Some physicists find this landscape unsettling, even distasteful, because it seems to replace a unique set of fundamental laws with a random lottery of possibilities. Others see in it a potential explanation for otherwise puzzling facts, such as the tiny but non-zero value of the cosmological constant that drives cosmic acceleration. In a multiverse of many possible constants, we naturally find ourselves in one where the conditions permit the formation of complex structures and observers. This reasoning, known as the anthropic principle, is controversial, for it shifts part of the explanation for physical laws from necessity to selection. The philosophical questions multiply. If there are indeed countless other universes, does it even make sense to speak of everything as including only what we can see? Are we then like fish in a pond, believing the pond is all there is, while an unseen ocean lies beyond? Or are we more like a single cell in a boundless organism, our existence one local expression of a deeper and more intricate whole? And yet, even as these thoughts expand the imagination, they confront us with a profound limitation. In most versions of the multiverse, other bubbles are forever beyond our causal reach. The space between us and them is inflating so rapidly that no signal, not even light, can cross it. We can never visit them, never receive a message from them, never send a probe to explore them. If so, then the multiverse may be as much a metaphysical idea as a physical one, a framework that extends our theories but not our observable domain. There have been bold proposals for possible indirect evidence. Some theorists suggest that if two bubbles collided in the distant past, the scars of that collision might be imprinted as subtle circles or distortions in the cosmic microwave background. Others imagine that the pattern of dark energy might carry clues about the landscape of vacua. So far, no compelling sign of such evidence has been found. The sky's ancient light remains smooth, save for the tiny fluctuations predicted by ordinary inflation. The multiverse remains, for now, a hypothesis without observational confirmation. This gap between theory and evidence is not merely a technical hurdle. It raises deep questions about the nature of science itself. Science has always been built on the principle of testability, of hypotheses that can in principle be confirmed or refuted by observation. A realm forever beyond observation strains that principle. Are we justified in speaking of such realms as physically real? Or are they mathematical extrapolations of our models, like the distant branches of an unfinished equation? Some physicists argue that if a theory that predicts a multiverse also makes successful predictions about observable phenomena, as inflation does for the pattern of the cosmic microwave background, then we have reason to accept its further implications, even if we cannot test them directly. Others insist that this stretches science too far, blurring the line between empirical investigation and metaphysical speculation. The debate is ongoing, reflecting not only differing judgments about evidence, but also differing philosophical temperaments. What is clear is that the multiverse, if real, transforms our sense of significance. It replaces the image of a single cosmos, vast but unified, with an image of an unending plurality of worlds. The word everything ceases to mean what it once did. Our observable universe becomes a local province, our laws of physics local statutes, our history a parochial chronicle in a greater, unknowable expanse. This realization can evoke both awe and dread. Awe at the immensity of the possible. Dread at the thought that we may never transcend our own bubble, that we will always be confined to this one cosmic island, never to see the others across the eternal gulf. The multiverse offers an ultimate elsewhere that remains forever out of reach. Philosophers have long wrestled with the idea of plurality. Ancient atomists imagined infinite worlds arising in the void. Medieval thinkers debated whether God might have created more than one world. The multiverse resurrects these old questions in a new key, rooted not in metaphysical speculation, but in modern physics. Yet the emotional resonance is much the same. A humbling of our claim to centrality, a challenge to the notion that we inhabit the whole. We might picture the multiverse as a vast field of shimmering cells, each a region of space-time cooled from an inflating background. Some cells may be sterile, empty, or short-lived. Others may bloom with galaxies and life. Our bubble is one such cell, fortunate in its conditions. We are like organisms thriving in a single oasis amid a cosmic desert, surrounded by realms we will never visit. If such a picture is correct, it reframes the question of origins. The question, why is there something rather than nothing, becomes, why is there this particular bubble rather than another? Or even, Why is there this inflationary field giving rise to bubbles at all? Each answer opens into a deeper mystery. Each reveals our knowledge as bounded, our theories as partial glimpses of a larger pattern. In recent years, some cosmologists have speculated that the laws of physics themselves may evolve in a kind of cosmic natural selection across the multiverse, favoring regions that give rise to black holes or to certain structures. Others seek a final theory that will uniquely specify the properties of our universe and perhaps of all others. Whether such efforts can ever succeed remains unknown. What remains constant is the human perspective. Whatever the vastness beyond our bubble, we inhabit this one. Our telescopes peer across billions of light years, but see only within this local patch. Our experiments probe the microphysics of particles and fields, revealing clues about early moments. Yet they too are confined to this cosmic domain. We may imagine, infer, even believe in the others, but we will live and die within the horizon of our bubble. There is a poignant lesson in this. We began our journey by asking where the universe ends. We learned that the edge is not a place, but a horizon in time. We discovered that space itself may curve back on itself, that there may be no outside in the classical sense. And now we confront the possibility that beyond our observable bubble, there may lie innumerable other universes, forever separate. Our horizon is both a window and a wall. A window onto the deep past of our own cosmos, a wall against any glimpse of the others. As the night sky spreads above us, filled with ancient light, it is easy to feel small, even insignificant. But that same sky, whatever lies beyond it, is also our home. It is the bubble within which atoms assembled into stars. Stars forged the elements of life, and life awakened to wonder. If the multiverse is real, then we are a local story in a grander epic. But a story nonetheless, the story we can know, the story we can cherish. And so, we end this section, as we began, with a mixture of wonder and humility. There may be more universes than grains of sand on Earth. There may be no way to reach them, no hope of hearing their distant songs. The edges of our bubble recede forever, as fast as we chase them. And if the multiverse is real, then even the word everything no longer means what it once did. It becomes a horizon that moves away as we advance, an invitation to endless curiosity, and an acknowledgement of enduring mystery. We have crossed oceans of thought to reach this point in the story. We have stepped past horizons that once felt final. The edge of the world, the dome of the sky, the Milky Way as the whole of creation, the observable universe as the ultimate totality. With each step, the scale of reality has grown, and with it, the sense of our own smallness. Yet something curious has happened along the way. As the known universe has expanded in size and mystery, the importance of the questions we ask about ourselves has not diminished. If anything, it has deepened. The more we learn that we are small, the more meaningful our questions become. Perhaps this is because meaning is not measured in kilometers or light years. It is measured in the power to wonder, to reflect, to ask why. A child staring up at the night sky feels awe, not because the stars care about her, but because she senses that they exist at all, that she can look at them and ask where they came from. That spark of curiosity is a thread connecting us to the long line of thinkers who once gazed into the heavens and tried to imagine what lay beyond the horizon. There is a paradox at the heart of this story. Science has relentlessly stripped away illusions of centrality. We are not at the center of the solar system, nor the galaxy, nor the visible universe. The universe itself may not be all there is. Our cosmic address has shifted outward from the heart of creation to a tiny world circling an ordinary star in one galaxy among billions, perhaps in one bubble among countless others. And yet, at the same time, we have discovered that we are the only known part of this vast structure able to ask such questions and seek answers. The more peripheral our physical location, the more significant our capacity for thought appears. Long before telescopes and theories, our ancestors wove the night sky into stories. Constellations were hunters and heroes, animals and spirits. The vault above was seen as the roof of the world, the outside as a realm of gods or monsters. Creation myths offered boundaries, a beginning, a shaped cosmos, a reason for existence. The transition from those ancient visions to the modern scientific view was not only a change of information, it was a change of frame. We replaced a cosmos of designed compartments with one of evolving processes. We lost a sense of enclosing walls and gained a sense of open-ended history. With that change came new kinds of meaning. When we believed the sky was a solid dome, our significance was tied to a central place. When we learned we were on a planet orbiting a star in a galaxy, adrift in expanding space, we had to seek significance elsewhere. In our ability to understand, to perceive patterns, to share knowledge across generations. The story of the universe became not merely the backdrop for human lives, but a story in which we participate as witnesses, translators, and storytellers. The discovery that there may be no outside, that space is not a container but the whole fabric, has pushed this transformation still further. We cannot appeal to some outer realm as the source of purpose. We cannot imagine that meaning lies in a higher chamber beyond the universe's edge. Instead, we must find it within the unfolding of the cosmos itself, and in our own responses to that unfolding. The absence of an outside is not the absence of wonder. It is the recognition that wonder arises from within. To appreciate this shift, consider again the image of a candle burning in a vast cathedral. The flame's glow reveals arches and distant walls, but never illuminates the whole. Beyond the light is not another building, only more of the same cathedral stretching into shadow. In the same way, our science shines a light on portions of reality, but the darkness beyond is not a separate domain. It is the still unseen part of the same totality. We do not need an exterior to evoke the sense of the sacred. The vastness itself, self-contained, is enough. For some, the realization of our cosmic smallness provokes a feeling of insignificance. How can a fragile species on a minor planet matter in a universe whose scale defies comprehension? Yet for others, this very smallness is a source of humility and connection. To be part of the same continuum that produced galaxies, stars, planets, life, and thought is to belong to the greatest story we know. The grandeur lies not in our size, but in our participation. The sense of participation is crucial. We are not merely passive spectators. We are made of the same atoms forged in stars. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were created in stellar furnaces and scattered by supernovae. The universe did not merely give rise to us. We are a way in which it has become aware of itself. To ponder the absence of an outside is itself a cosmic act, the fabric reflecting on its own nature. Culture has always mirrored this evolving perspective. Ancient epics sang of walls at the edge of the world, of heavens above and nether regions below. Medieval maps showed monsters lurking beyond the known seas. The Enlightenment replaced mythic edges with coordinates and laws of motion. The 20th century added relativity and quantum theory, showing that even space and time are dynamic. Now we face a universe possibly infinite, possibly one of many, with no exterior border. Each cultural frame shaped how we thought about ourselves and our purpose. The philosophical implications are profound. If there is no outside to the universe, no beyond to which we can point, then questions about ultimate origin shift from asking, "Where did it come from?" to "Why does it have this particular structure, these laws, this history?" The search for meaning becomes more interior, less about location and more about relation. The relation between consciousness and the cosmos, between fleeting lives and enduring processes. Some find in this picture a kind of existential vertigo. The absence of a final enclosure feels like the absence of a foundation. Others find it liberating, a release from parochial frames. The universe, self-contained and vast, is neither for us nor against us. It simply is. Our task is not to conform to some external order, but to create significance through our actions, insights, and shared narratives. The human journey through knowledge reflects this shift. We built myths to impose order, then replaced them with observation and reason. We learned to see that the Earth is a sphere, that the planets move around the sun, that the stars are distant suns, that galaxies fill the void, that the void itself is expanding. Each revelation has been both a dethronement and an enlargement. It has forced us to let go of comforting illusions, but has also given us a deeper, more intricate reality to explore. The idea of no outside continues this pattern. It asks us to let go of the final illusion of a surrounding frame. It places us fully within the story we are telling, without appeal to a beyond. And in doing so, it invites a new kind of meaning. One rooted not in hierarchy, but in participation, not in special location, but in shared being. Philosophers and poets have often intuited this. Blaise Pascal wrote of the infinite spaces that frightened him. Rainer Maria Rilke spoke of being at home in the vastness. Carl Sagan reminded us that we are star stuff contemplating the stars. These voices, separated by centuries, echo a common theme, that human dignity lies not in centrality, but in awareness. Awareness carries responsibility. To recognize that we live in a self-contained cosmos with no outside is to see that we cannot outsource the making of meaning to an external authority. We must create it in our relationships with each other, with the living world around us, with the fragile planet that shelters us. Our questions about purpose must be answered in terms of the values we choose and the futures we shape. Science, far from robbing us of meaning, has enriched it by revealing the deep kinship between all things. The atoms in a child's hand and the atoms in a distant galaxy obey the same laws. The light that leaves a star can cross billions of years to enter a human eye and spark a thought. Knowledge binds us to the cosmos even as it humbles us. Consider again the child looking up at the night sky, eyes wide with wonder. She does not know about general relativity or quantum fields. She sees points of light scattered in darkness and senses that they are ancient, distant, and somehow connected to her own being. That sense of connection is the seed of all later understanding. It is the bridge between the small and the vast. As a species, we are still that child. Our instruments extend our sight. Our theories deepen our grasp. But we remain at the beginning of understanding. The story of the universe is still being written, and we are one chapter in it. Our questions about origins, destiny, and purpose arise not from outside, but from within the unfolding tale. The universe does not dictate their answers, but it provides the stage on which we ask them. In this perspective, the lack of an outside is not a void of meaning, but an invitation. It invites us to seek significance in the very act of seeking, to value the fleeting moment of consciousness as part of the grand sweep of cosmic time. It suggests that the measure of our lives lies not in their scale compared to the universe, but in the depth of engagement we bring to them. As we look back on the journey, from the first sailors who feared falling off the edge of the world, to the astronomers who mapped the cosmic microwave background, from myths of enclosing shells to the realization of an ever-expanding, possibly boundless continuum, we can see that each step outward has also been a step inward. Each expansion of the known has asked us to rethink who we are. We end not with a final answer, but with a recognition. We are finite beings in a possibly infinite or unbounded cosmos. We seek meaning not by finding an edge, but by understanding our place within the whole. Our role is not to conquer the universe, but to learn, to wonder, to care for the fragile world that sustains us, to keep the flame of curiosity alive. In the cathedral of the cosmos, we are both the candle and the witnesses to its light. The more the light spreads, the more we see of the vast arches overhead, and the more we feel the mystery of what remains in shadow. The journey of understanding has no final wall, but it has milestones, and each milestone changes the story we tell about ourselves. The paradox remains. The more we know that we are small, the more profound our questions become. The absence of an outside does not diminish our quest. It intensifies it. It reminds us that meaning is not something to be found at the edge, but something to be made in the midst of the great expanse. And that, perhaps, is the most human truth we have yet discovered. We began with a simple, almost childlike question. Where does the universe end? We imagined it as a vast container with walls, a grand but finite chamber. As we followed the evidence, the walls dissolved. The horizon turned out to be not a rim in space, but a boundary in time. The expansion was not the growth of a balloon into a void, but the stretching of the fabric itself. The farther we looked, the more the notion of an outside slipped through our fingers. In searching for the edge of the universe, we discovered the boundless nature of our own imagination. This discovery is both humbling and liberating. It humbles us because it reveals that our most intuitive questions may be ill-posed. It liberates us because it invites us to see reality not as something with borders to be crossed, but as something that deepens with each layer of understanding. The journey outward becomes a journey inward. The farther the telescopes peer, the further the mind must reach beyond its old assumptions. To stand beneath a night sky strewn with stars is to feel this paradox in the marrow. The points of light are both near and far. Near enough for their photons to fall upon our eyes, far enough to remind us of the age and scale of the cosmos. Each star is a sun, each cluster a distant city of suns, and yet all are part of the same ongoing story. We are not outside of it. We are woven into the same fabric. In the early days of exploration, the edges we feared were cliffs at the rim of the world or the ends of the seas. Later, as we launched spacecraft, the edge seemed to be the border of our solar system, then of our galaxy. Now we know that the real frontier is not a place, but a limit of knowledge. The shifting line between what can be observed and what remains forever hidden beyond the reach of light. The horizon is not a fence, but a shadow cast by time. This recognition changes the meaning of exploration. The ultimate frontier may not be the end of space, but the depth of understanding we can reach. Every advance in physics, from Newton's law of gravitation to Einstein's curved space-time, from quantum theory to the study of dark energy, has expanded that depth. Our most powerful telescopes, like the James Webb and the next generation of space observatories, are designed not to find an outer wall, but to glimpse ever further back in time, to the first galaxies, perhaps to the subtle signatures of inflation itself. Our next great theories may reveal how gravity and quantum mechanics fit together, hinting at why the cosmic fabric has the properties it does. But the central paradox will remain. We can map the visible, infer the unseen, even speculate about other bubbles beyond our cosmic domain. Yet we cannot step outside the totality to look at it from beyond. There is no cosmic balcony from which to view the whole. We are in the story, not outside it. And so the ultimate questions: why there is something rather than nothing, why the fabric has these laws rather than others, remain open, not because we are failing to reach the edge, but because there may be no edge at all. This is not a cause for despair. It is the source of wonder. If there is no final wall to be found, then the horizon of discovery will always move with us. Knowledge will always open into more mystery. In that sense, the infinite is not merely a property of space, but a property of our encounter with it. The mystery is inexhaustible because we ourselves are part of it. Consider a drop of water falling into the ocean. The drop has shape and boundaries while it falls, but the moment it touches the sea, it merges into a vaster whole. In contemplating the universe, we are like that drop. For a moment we have the sense of separateness, the urge to find the edges, and then we realize that we have always been part of the ocean. The ocean does not need a shore to be real. The same thought can be expressed in another image: a camera zooming out through clouds, mountains, cities, continents, the blue sphere of Earth, the solar system, the galaxy, the cosmic web. As the zoom continues, galaxies become specks. Filaments fade into a haze. The picture grows dark. Not because we have reached an edge, but because light has not yet had time to arrive from further away. The screen fades to black, yet we know the story goes on beyond the darkness. The unseen is not nothing. It is simply beyond our reach. In this final view, curiosity itself becomes the defining human trait. Our species is united not by geography or creed, but by the shared capacity to wonder. Long before science, we wondered at the seasons and the stars. Long after we send probes to distant worlds, we will still wonder what lies beyond the next horizon of understanding. The infinite, as it turns out, is not just out there. It lives in the mind's refusal to stop asking. Such wondering has practical consequences. It has driven us to build instruments that extend our senses, to collaborate across cultures and generations, to develop languages of mathematics and experiment that let us share discoveries. It has also shaped our moral imagination, reminding us that in the face of the vastness, our quarrels are parochial, our common home fragile. We have seen Earth as a pale blue dot against the black, and that sight has changed how we think about war, about care for the planet, about our future. There is hope in this shared vision. The mystery of the universe's nature is not a barrier that divides us, but a horizon that invites collective exploration. Whatever our differences, we are all part of the same unfolding story. We live under the same sky, subject to the same laws of physics, heirs to the same cosmic history. To recognize this is to see that curiosity and wonder are common ground. The future of discovery will be shaped by this shared quest. We will launch more powerful telescopes to capture the faintest light from the dawn of time. We will refine our theories to probe the union of the very large and the very small. We will continue to ask what set the universe in motion, what shaped its laws, whether there are other domains beyond our cosmic bubble. Each answer will likely give rise to deeper questions. The frontier will not be a line we cross, but a depth we plumb. Perhaps this is the final lesson, that our role is not to reach an ultimate end, but to take part in an ongoing dialogue between the finite mind and the infinite mystery. To ask questions is not to confess ignorance, but to celebrate our participation in the great unfolding. The paradox of a universe with no outside thus becomes a metaphor for our own nature. We live within the whole, yet we carry within us the desire to step beyond. And it is that desire, never fully satisfied, that keeps the story alive. As we close this journey, picture once more a child standing beneath the night sky, holding her breath as she looks upward. She knows nothing of inflation, of cosmic horizons, of relativity or quantum fields. She feels only that the sky is vast, and that she wants to know what it means. In that simple longing is the seed of all science and philosophy. It is a longing that no final answer can quench. And perhaps that is why the cosmos appears as it does, to call forth the questions. The drop merges with the ocean. The camera's zoom fades to black. The horizon retreats as we advance. And in the dark, we keep wondering. That wonder is not diminished by our smallness. It is made possible by it. We are finite beings able to glimpse the infinite, and that glimpse is enough to inspire lifetimes of seeking. The ultimate frontier, then, is not a distant wall of space, but the depth of understanding we can reach, the compassion we can extend to one another, the wisdom we can draw from the recognition that we are part of a vast and ancient whole. The quest to know the cosmos is also the quest to know ourselves, to know what it means to be conscious, curious, fragile, and yet capable of insight. As the story continues, as telescopes peer further, as equations probe deeper, as generations pass the flame of inquiry, the mystery of the universe's boundless nature will remain. But so too will remain the light of human curiosity, a small, steady candle that glows in the cathedral of the cosmos. The more we learn, the more we see that the cathedral has no enclosing wall, and the more precious that candle becomes. Perhaps that is the true answer beyond all questions. Not a final explanation, but a recognition of our place as questioners in a reality that has no edge. In seeking the boundary, we discover not an ending, but a horizon that moves with us. And beyond that horizon lies not emptiness, but possibility. The mystery itself is the invitation, and our capacity to wonder is the response.